Welcome to deep science sleep. Picture yourself settling into the most comfortable position you've found all day. The weight of the world outside these walls begins to dissolve, replaced by a gentle curiosity about the mysteries that make our universe so beautifully strange. Tonight, we're going to explore the unexplained not with anxiety or fear, but with the peaceful wonder of a child looking up at stars for the first time. These are the phenomena that remind us how much magic still exists in our world, how many questions remain unanswered, how much there is still to discover. Let the rhythm of these stories carry you into rest, knowing that tomorrow, scientists will wake up and continue their patient work of understanding, while tonight, we simply marvel at what we don't yet know, ancient mysteries written in stone. Deep in the rolling hills of southeastern Turkey, there exists a place that fundamentally changed our understanding of human history. Göbekli Tepe stands as a testament to capabilities we never imagined our ancestors possessed. When you close your eyes and imagine this sight, picture massive stone pillars arranged in circles, their surfaces covered with intricate carvings of animals that roamed the earth more than 11,000 years ago. These aren't simple markers or crude monuments. These are sophisticated architectural achievements created by people we once believed lived only as simple hunter-gatherers, moving from place to place, barely surviving. The site's very existence challenges everything we thought we knew about the birth of civilization. For decades, the prevailing theory suggested that humans first learned to farm, then settled down, and only after establishing permanent communities did they develop the organizational capacity to build monuments. Göbekli Tepe turns this narrative completely upside down. The people who built this place were still hunting wild game and gathering wild plants, yet they somehow coordinated the efforts needed to quarry, carve, transport, and erect stones weighing up to 16 tons each. Some of these pillars stand 5.5 meters tall, carved entirely with flint tools in an age before metal. The mystery deepens when you consider the logistics. Recent excavations have revealed living quarters, extensive areas for processing cereals, sophisticated water collection systems carved directly into the bedrock, and tools associated with permanent settlement. This contradicts earlier interpretations that Göbekli Tepe served solely as a ceremonial destination visited by nomadic peoples. The residential structures discovered in recent years tell us that people lived here, worked here, created here. They developed a water harvesting system consisting of carved channels feeding multiple cisterns that could hold at least 150 cubic meters of water. This level of engineering speaks to planning, foresight, and a deep understanding of their environment. What makes the carvings particularly fascinating is their apparent purpose. The massive T-shaped pillars feature detailed reliefs of foxes, lions, bulls, scorpions, vultures, and other creatures. Some researchers interpret these as representations of a cosmological calendar, possibly even recording a catastrophic comet strike that occurred around 10,850 BCE. One pillar, known as Pillar 43, contains V-shaped carvings that some scientists believe represent days in a solar calendar, consisting of 12 lunar months plus 11 additional days. If this interpretation holds true, it would mean these ancient peoples were not only keen observers of the sky but possessed mathematical sophistication far beyond what we previously credited to societies of that era. The comet theory itself adds another layer of wonder to the mystery. Evidence from soil sediments in North America and Greenland shows elevated levels of platinum and nanodiamonds, along with materials altered by extreme temperatures, all dating to roughly the same period. This global evidence suggests a comet impact that triggered a mini ice age lasting over 1,200 years, potentially causing the extinction of many large animal species and fundamentally altering the climate. The people of Göbekli Tepe may have witnessed this event, carved it into permanent stone as a warning or remembrance, and in doing so created one of humanity's earliest attempts at preserving knowledge across generations. What's particularly soothing about this mystery is its incompleteness. We've excavated only about 10% of the site. Current estimates suggest the full excavation will take approximately 150 years. Archaeologists believe at least 15 more enclosures remain buried underground, one of which might date back 15,000 years, making it even older than the structures we've already discovered. There's something peaceful in knowing that future generations will continue this work, that the story of Göbekli Tepe will unfold slowly over centuries, revealing its secrets bit by bit to patient researchers who dedicate their lives to understanding. The site reminds us that human ingenuity and the drive to create something lasting has existed far longer than we ever imagined. These ancient people gathered from an area spanning 200 kilometers to perform rituals, to build, to carve, to express something profound about their relationship with the animals around them and the cosmos above them. They worked without the benefit of metal tools, without written language as we know it, without any of the technological advantages we consider essential. Yet they created something that has lasted 11,000 years and continues to inspire wonder today. Among the recent discoveries is a magnificent painted wild boar statue from Enclosure D, featuring red, white, and black pigments still visible after all these millennia. The statue measures approximately 1.35 meters wide and 0.7 meters tall, with carefully carved tusks, a prominent tongue, and what some researchers interpret as depictions of human heads, possibly symbolizing the transition of spirits into the afterlife. These artistic choices reveal a sophisticated symbolic vocabulary, a shared understanding of metaphor and meaning that bound communities together across vast distances. Another recent find includes a human statue standing 2.3 meters tall, featuring detailed facial features with sharp contours, deep-set eye sockets, and a prominent nose. This represents a revolutionary moment in prehistoric art, where abstract symbolism evolved into direct human representation. The statue suggests these ancient peoples possessed a concept of individual identity and human form worth commemorating in stone, an acknowledgement of human consciousness and self-awareness that feels remarkably modern. The mystery of Göbekli Tepe isn't frightening or unsettling. Instead, it's humbling and somehow comforting. It reminds us that humans have always looked up at the stars, wondered about their place in the cosmos, and worked together to create meaning from that wonder. The site stands as proof that the impulse to understand, to commemorate, to leave something behind that says we were here, we thought, we mattered, is as old as civilization itself, perhaps even older. As you drift towards sleep, imagine standing among those ancient pillars at dawn, the first light touching stones that have witnessed 11,000 sunrises. Imagine the hands that carved those animals, the voices that coordinated that massive construction effort, the eyes that looked up at the same constellations you can see tonight. We are connected to those ancient people through an unbroken chain of human curiosity and wonder, and that connection spans more years than our minds can easily comprehend. Yet it feels intimate somehow, like recognizing yourself in a very old photograph. Whispers from the cosmos. The universe speaks to us in many languages, but few are as mysterious and captivating as fast radio bursts. These are intense flashes of radio waves that last mere milliseconds yet release more energy than our sun produces in 3 entire days. Imagine the power compressed into that briefest moment. A cosmic shout so intense it travels across billions of light years and still arrives at our instruments with enough strength to be detected and measured. The first fast radio burst was discovered by astronomer Duncan Lorimer and his student David Narkevic in 2007, while searching through archival data from pulsar surveys. They found something so unusual it was initially thought to be an error or terrestrial interference. The signal, now known as the Lorimer burst, came from outside our galaxy, from a source so distant and so powerful that it defied easy explanation. Since that discovery, astronomers have detected thousands of these bursts, each one a puzzle piece in a larger cosmic mystery we're only beginning to understand. What makes fast radio bursts particularly intriguing is their unpredictability and variety. Most appear once and never repeat, flashing into existence for a few milliseconds and then vanishing forever. However, a small percentage do repeat, and these repeating sources have given astronomers rare opportunities for extended study. One such repeater, designated FRB 121102, was identified with a galaxy approximately 3 billion light-years away, embedded in an extreme environment of intense magnetic fields and energetic processes we don't yet fully understand. The mystery deepened significantly in January 2025, when astronomers discovered a fast radio burst emanating from what they call a dead galaxy. This repeating burst, FRB 202402009A, was first detected in February 2024 and produced 22 bursts over several months. What shocked researchers was its location on the outskirts of an ancient, massive elliptical galaxy where star formation ceased billions of years ago. This discovery shattered previous assumptions that fast radio bursts exclusively come from regions of active star formation where young, massive stars create the conditions necessary for these phenomena. The prevailing theory had suggested that fast radio bursts originate from magnetars, which are neutron stars with extraordinarily powerful magnetic fields. Magnetars are typically formed when massive stars explode as supernovae, a process that only occurs in regions with ongoing star formation. Finding a fast radio burst in a galaxy with no new stars being born means either we don't fully understand where magnetars come from, or fast radio bursts have multiple origins we haven't yet identified. Some researchers now propose that this particular burst might originate from a globular cluster, a dense collection of old stars where magnetars could form through alternative mechanisms, perhaps from the merger of two neutron stars or from a white dwarf collapsing under its own gravity. Even more fascinating revelations emerged when researchers using China's 500-meter aperture spherical telescope detected evidence that at least some fast radio bursts originate in binary star systems. For nearly 20 months, they monitored FRB 220529A, a repeating source located about 2.5 billion light-years away. At its peak activity, this source produced more than 200 bursts per hour, an astonishing rate that provided abundant data for analysis. The key discovery came from studying the polarization of the radio waves, specifically a phenomenon called rotation measure, which reveals how radio waves twist as they pass through magnetized plasma. The researchers observed a sudden, dramatic change in the rotation measure, consistent with a coronal mass ejection from a companion star passing between the fast radio burst source and Earth. This provided the first definitive evidence that some fast radio burst sources aren't isolated neutron stars but rather exist in binary systems, orbiting a companion star similar to our Sun. This discovery supports a model where interactions within binary systems create the special geometry and conditions that allow magnetars to produce frequent, repeating bursts. Meanwhile, in March 2025, astronomers detected what they informally nicknamed RBFLOAT, standing for Radio Brightest Flash of All Time. This ultra-bright fast radio burst originated from a spiral galaxy in the constellation Ursa Major, approximately 130 million light-years away. The detection represents one of the closest and brightest fast radio bursts ever recorded, giving scientists an unprecedented opportunity to study the environment from which these mysterious signals emerge. The burst came from the very edge of an active star formation region, providing crucial clues about the relationship between fast radio bursts and their cosmic neighborhoods. What's beautifully calming about the mystery of fast radio bursts is how they represent the universe constantly surprising us. Just when astronomers thought they understood the pattern, that fast radio bursts came exclusively from young, star-forming galaxies, the cosmos revealed a burst from an ancient, quiet galaxy. When scientists assumed fast radio burst sources were isolated neutron stars, observations showed that some exist in binary systems with companion stars. Each new discovery doesn't close the mystery, but rather opens it wider, revealing layers of complexity we hadn't imagined. The Canadian Hydrogen Intensity Mapping Experiment, or CHIME, has revolutionized fast radio burst detection since it began observations in 2018. This telescope consists of 4 large, stationary receivers shaped like half-pipes, tuned to detect radio emissions across frequencies particularly sensitive to these cosmic flashes. Since 2020, CHIME has detected thousands of fast radio bursts from across the universe. Recently, the addition of CHIME outriggers, 3 miniature versions of CHIME located at different sites across North America, has dramatically improved the ability to precisely locate these bursts, enabling astronomers to identify the exact galaxies and even specific regions within galaxies where the bursts originate. Perhaps the most remarkable aspect of fast radio bursts is their sheer power paired with their fleeting nature. These cosmic phenomena release as much energy in milliseconds as our Sun emits over 3 entire days. Yet by the time those radio waves reach Earth after traveling across billions of light-years of space, their strength has diminished to about 1,000 times less than the signal from a mobile phone on the Moon. The fact that we can detect them at all speaks to both the incredible sensitivity of modern radio telescopes and the astonishing energy of the original events. As you settle into sleep, consider the comfort in knowing that even now, radio telescopes around the world are silently listening to the universe. Fast radio bursts are flashing across the cosmos at this very moment, some from galaxies so distant their light began its journey to us before Earth even existed. These mysterious signals remind us that the universe is far more active, more energetic, and more surprising than we ever imagined. They're proof that no matter how much we learn, there will always be new mysteries waiting to be discovered, new questions to ask, new wonders to contemplate. The universe isn't finished surprising us, and that's not something to fear. It's something to find peace in, knowing that curiosity and wonder will never run out, that there will always be another mystery just over the horizon, waiting for patient observers with their instruments pointed at the stars. Tonight, as you drift off, fast radio bursts are traveling through the dark between galaxies, carrying secrets we haven't yet learned to decode, promising that tomorrow's astronomers will have mysteries just as captivating as those being solved today. Nature's impossible performances. Our planet has a way of creating spectacles that seem to defy the laws of physics, phenomena so unusual that witnessing them feels like stepping into another reality. Among these mysterious performances, ball lightning stands as one of nature's most persistent enigmas, reported for centuries yet remaining stubbornly difficult to study or even definitively prove exists. Imagine a luminous sphere, roughly the size of a grapefruit, glowing with the approximate brightness of a household lamp. It appears suddenly, often after a lightning strike, floating through the air with apparent purpose, moving horizontally at a few meters per second or sometimes standing eerily still. It might drift along power lines or metal fences, seeming to have an affinity for conductors. It can persist for anywhere from 1 second to over a minute, its brightness remaining remarkably constant throughout its brief existence. Then, just as mysteriously as it appeared, it vanishes, either silently fading away or, in some reports, exploding with a sharp crack or loud bang. Ball lightning has been reported throughout history, with descriptions appearing in accounts dating back centuries. Yet despite thousands of eyewitness reports, including observations by trained scientists, the phenomenon remains elusive. It's never been reliably created in a laboratory, and confirmed photographic or video evidence remains scarce. A 2014 publication included what appears to be the first optical spectrum of ball lightning, along with high frame rate video, but even with modern technology, catching this phenomenon remains extremely rare. The challenge with studying ball lightning lies in its unpredictable nature. Unlike regular lightning, which can be studied during any thunderstorm, ball lightning appears sporadically, in locations that can't be predicted, and lasts for such a short time that by the time anyone thinks to grab a camera or measurement device, it's usually gone. Lightning researcher Carl Berger spent his entire career registering and measuring hundreds of thousands of lightning strikes at his laboratory atop Mount Salvatore in Switzerland without ever capturing a single instance of ball lightning. The phenomenon simply doesn't occur at the high points where traditional lightning research takes place. The typical ball lightning report describes a sphere 1 to 25 centimeters in diameter, though sizes ranging from pea-size to several meters across have been documented. Colors vary widely, with red, orange, and yellow being most common, though blue, white, and green balls have also been reported. Most observers note that despite the light's brightness, they don't feel significant heat, though in some cases the disappearance of the ball releases enough energy to singe wood or leave behind the smell of ozone and nitrogen oxides. What makes ball lightning particularly fascinating is its reported behavior indoors. Multiple witnesses have described seeing these luminous spheres pass through closed windows and doors, sometimes leaving small holes, other times apparently passing through glass without causing any damage. They've been spotted inside metal aircraft, entering and exiting without leaving a trace. These accounts seem to defy our understanding of how physical objects interact with barriers, adding another layer of mystery to an already puzzling phenomenon. Several theories have been proposed to explain ball lightning. One suggests it's a form of plasma created by lightning strikes, possibly involving silicon vaporized from soil. Another proposes it's an electromagnetic phenomenon involving standing waves of ultra-high-frequency radiation. Some researchers theorize it might be a microwave-powered discharge, while others suggest it could be related to chemical reactions involving vaporized material from lightning strikes. Each theory explains some observed characteristics but struggles to account for others, and none has successfully reproduced ball lightning in a controlled laboratory setting in a way that matches all the eyewitness descriptions. An intriguing alternative explanation suggests that some ball lightning reports might actually be phosphenes, visual phenomena caused by the magnetic fields from nearby lightning strikes stimulating neurons in the observer's visual cortex. Research with transcranial magnetic stimulation has shown this can create luminous sphere hallucinations similar to ball lightning descriptions. However, this theory fails to explain cases where multiple people saw the same ball lightning simultaneously, or instances where the phenomenon left physical evidence like burn marks or small holes in glass. Recent video evidence evaluated by scientists in 2025 shows what may be ball lightning objects moving near a camera during a thunderstorm, with velocities and estimated brightness consistent with typical eyewitness accounts. The objects appeared spherical, moved at speeds between 20 and 38 meters per second, and displayed the characteristic glow described in historical reports. While not definitively proven to be ball lightning, such recordings represent important steps toward gathering objective data on this elusive phenomenon. The mystery of ball lightning isn't unsettling in the way ghost stories might be. Instead, it's a gentle reminder that despite all our scientific instruments and sophisticated theories, nature still manages to surprise us with phenomena we can't fully explain or predict. It suggests that on any given day, during any thunderstorm, something extraordinary might happen, something that defies our expectations and expands our sense of what's possible. As you close your eyes tonight, imagine ball lightning as nature's way of showing off, of reminding us that the world contains more magic than our theories can currently encompass. Picture those luminous spheres drifting through the air, their glow reflecting off surfaces, their movement graceful and purposeful yet guided by laws we don't yet understand. There's something almost playful about the phenomenon, as if the universe occasionally breaks its own rules just to keep us wondering, just to ensure we never become too confident in our complete understanding of the natural world. The fact that ball lightning remains unexplained after centuries of reports and decades of scientific investigation isn't frustrating. It's wonderful. It means that nature still holds surprises, still has tricks up its sleeve, still can present us with mysteries that resist our best efforts to solve them. It means that tomorrow's scientists will have puzzles to work on, phenomena to chase, questions to pursue. And perhaps most comforting of all, it means that the world is still wild enough, still unpredictable enough, to occasionally produce wonders that leave even trained observers speechless with amazement. Beyond ball lightning, Earth's atmosphere creates other mysterious light shows that blur the boundary between the explained and the unexplained. Red sprites and blue jets, ethereal lightning phenomena that occur high above thunderstorms, were only confirmed to exist in the late 20th century, despite reports dating back decades. These brief flashes of colored light happen in the upper atmosphere, too high and too quick to be easily observed from the ground. Now we know they're real, captured on specialized cameras, their physics studied and gradually understood. Yet for years, pilots who reported seeing them were dismissed, their observations considered impossible. This pattern repeats throughout science. Phenomena reported by reliable witnesses but dismissed as impossible until technology advances enough to detect and measure them. It's a humbling reminder that the border between the known and unknown shifts constantly, that today's mystery might be tomorrow's textbook explanation, but also that new mysteries will always emerge to take their place. The universe seems endlessly creative in finding ways to surprise us. Sounds that shouldn't exist. The ocean keeps many secrets, and among its deepest mysteries are sounds that have no obvious source. In the summer of 1997, underwater microphones belonging to the National Oceanic and Atmospheric Administration detected something extraordinary. The sound rose rapidly in frequency over about 1 minute, loud enough to be picked up by sensors more than 5,000 kilometers apart. Researchers named it the bloop, and for years it remained one of the most intriguing acoustic mysteries of modern oceanography. The bloop's characteristics defied easy explanation. Its audio profile bore some resemblance to sounds produced by living creatures, particularly in how its frequency modulated, which reminded some listeners of whale vocalizations. However, the sheer power of the sound presented a problem. To be detected across such vast distances, it would need to be far louder than any sound produced by any known animal, including blue whales, the loudest creatures on Earth. Some researchers speculated it might come from an undiscovered deep-sea creature, perhaps something massive lurking in unexplored ocean depths. Others wondered if it might be related to underwater volcanic activity, submarine movements, or other geological processes. The mystery persisted for years, capturing public imagination and inspiring countless theories. The sound source was triangulated to somewhere in the South Pacific, west of the southern tip of South America, in waters so remote and deep that exploring them presented enormous technical challenges. As time passed and more similar sounds were detected, researchers at NOAA continued their patient work, deploying additional hydrophones closer to Antarctica, driven by a hunch that ice might be involved. Their persistence paid off. Between 2005 and 2010, acoustic surveys in the Bransfield Strait and Drake Passage revealed that ice breaking up and cracking was a dominant source of natural sound in the Southern Ocean. The bloop's distinctive signature matched that of icequakes, the tremendous fractures that occur when massive icebergs calve from Antarctic glaciers. The mystery was solved. The bloop was the sound of an enormous ice event, likely a massive iceberg cracking and breaking away from its glacier, creating a sound so powerful it reverberated across thousands of kilometers of ocean. While this explanation might seem to diminish the mystery, it actually reveals something equally fascinating about our changing planet. With global warming accelerating, such icequake events occur more frequently as glaciers melt and massive ice shelves destabilize. Each bloop-like sound represents not just an acoustic event, but a marker of climatic change. A planet in transition making itself heard through the very medium that best carries sound across vast distances. The bloop wasn't alone. NOAA's hydrophone arrays have detected numerous unexplained sounds over the years, each given evocative names based on their acoustic characteristics. Julia, recorded in 1999, lasted about 2 minutes and 43 seconds and was loud enough to be heard across the entire equatorial Pacific Ocean autonomous hydrophone array. Like the bloop, it was eventually attributed to a large iceberg running aground off Antarctica. Slow Down, detected in 1997, earned its name from the way its frequency gradually decreased over about 7 minutes, creating a sound that resembled the friction of a massive ice sheet moving over land. One sound that remains partially mysterious is the upsweep, detected when NOAA first began recording its sound surveillance system in August 1991. The upsweep consists of a long train of narrowband sounds, each lasting several seconds, with the overall pattern continuing year after year. The sound appears to be seasonal, generally reaching peaks in spring and autumn, though it's unclear whether this variation comes from changes in the source itself or from seasonal changes in how sound propagates through ocean water at different temperatures and salinities. The upsweep source level is high enough to be recorded throughout the Pacific, suggesting a powerful and persistent phenomenon whose exact nature remains debated. What makes these ocean mysteries particularly soothing is their gradual resolution through patient observation rather than dramatic revelation. Scientists didn't solve the bloop mystery through a single eureka moment, but rather through years of deploying more hydrophones, recording more sounds, analyzing more data, and slowly building a comprehensive picture of what creates which acoustic signatures in the ocean. This methodical approach reflects science at its best. Persistent, careful, willing to wait years or even decades for enough data to draw firm conclusions. The ocean soundscape is far richer and more complex than most people realize. Beneath the waves, a symphony plays constantly. Whales sing to each other across hundreds of miles. Shrimp colonies create crackling choruses so loud they can interfere with sonar. Earthquakes rumble through the deep. Ice cracks and groans. Underwater volcanoes bubble and roar. And among all this natural sound, occasionally something unusual appears. Something that doesn't fit known patterns. Something that demands investigation and explanation. The hydrophones that detected the bloop were originally installed during the Cold War as part of the sound surveillance system, designed to track Soviet submarines. After the Cold War ended, many of these listening stations were declassified and repurposed for scientific research, creating an unintended benefit from military technology. This network now serves as Earth's ears beneath the waves, constantly monitoring the ocean's acoustic environment, tracking marine mammal populations, detecting underwater earthquakes, and occasionally catching mysterious sounds that become puzzles for researchers to solve. There's something deeply peaceful about knowing these hydrophones exist, silently listening to the ocean's hidden world. Right now, at this very moment, they're recording whale songs from animals swimming in darkness thousands of feet below the surface. They're detecting the low rumble of tectonic plates shifting gradually along fault lines. They're capturing the sounds of ice breaking in polar regions, each crack and groan a testament to a planet in constant flux. And perhaps, somewhere in tomorrow's data, they'll catch another mystery, another sound that doesn't fit known patterns, another puzzle for patient scientists to gradually, methodically solve. As you drift towards sleep, imagine the ocean's depths, where sunlight never reaches and pressure would crush any human visitor, yet where sound travels with remarkable clarity. Picture the hydrophones anchored to the seafloor, their sensitive instruments converting pressure waves into electrical signals, sending that data up cables to surface buoys, and from there via satellite to laboratories where researchers will eventually analyze every minute of recording. Consider the patience required for this work, the willingness to collect data for years before patterns emerge, the comfort in knowing that not all mysteries need immediate answers, that some can wait for the slow accumulation of evidence and the gradual building of understanding. The Bloop story has a satisfying completeness to it. Mystery detected, questions raised, theories proposed, data collected, explanation found. Yet the explanation itself, massive icebergs calving from Antarctic glaciers, carries its own note of mystery and wonder. These are events of such power they can be heard across thousands of miles of ocean. They represent forces we barely comprehend, climate processes operating on scales that dwarf human experience. In solving one mystery, science revealed another. Our planet is actively changing in ways we're only beginning to understand, and those changes echo through the deep ocean, creating sounds that travel the world. Rocks that walk when no one's watching. In a remote corner of Death Valley National Park lies a dry lakebed called Racetrack Playa, home to one of geology's most visually striking mysteries. Scattered across this flat expanse are rocks, some weighing as much as 700 pounds, each trailing behind it a long furrow in the hard mud, evidence of movement across distances, sometimes exceeding 1,500 feet. The trails snake and curve, occasionally making sharp turns or reversing direction entirely. Some rocks leave parallel tracks, as if traveling in formation. Others wander independently, their paths crossing and diverging in patterns that seem almost deliberately designed to baffle observers. The mystery deepened because despite over a century of scientific interest, from the early 1900s when the stones were first systematically documented, no one had ever actually seen them move. Researchers would visit the playa, photograph the stones and their trails, then return months or years later to find the rocks in new positions with fresh trails behind them. The stones were definitely moving, but how, when, and why remained completely unknown. Theories proliferated over the decades. Some suggested strong desert winds pushed the rocks during rare wet periods when the playa surface became slippery. Others proposed that the rocks became embedded in ice sheets that floated on winter water, with wind pushing the ice and the embedded rocks along with it. More fanciful explanations invoked magnetic fields, underground vibrations, even extraterrestrial intervention. None of these theories could be conclusively proven or disproven without direct observation of the movement, which seemed impossibly rare given that researchers estimated the rocks moved only a few minutes out of every million minutes they sat motionless. The breakthrough came through a combination of patience and new technology. In 2011, researchers led by paleobiologist Richard Norris from the Scripps Institution of Oceanography, along with his cousin James Norris and planetary scientist Ralph Lorenz, embarked on what they called the most boring experiment ever. They attached GPS units to 15 rocks and placed them on the playa, then installed a high-resolution weather station and time-lapse cameras. Their goal was simple: wait until the rocks moved, recording everything about the environmental conditions when movement occurred. They expected to wait 5 to 10 years. Instead, just 2 years into their project, on December 4th and 20th, 2013, The cameras captured rock movements for the first time in recorded history. The researchers even witnessed the events in person, watching dozens of rocks slowly sliding across the playa at speeds of about 7 to 16 feet per minute. Some rocks moved over 200 meters during the winter of 2013 to 2014, traveling in multiple movement events. The mystery was finally solved, and the answer was both simpler and more elegant than many of the exotic theories that had been proposed. The key was a precise combination of rare conditions. First, rain had to fall on the usually dry playa, creating a shallow pond. Then, overnight temperatures had to drop below freezing, creating a thin sheet of ice across the water. The ice needed to be just the right thickness, thin enough to break apart easily, but thick enough to maintain some structural integrity. As morning sun began melting the ice, it would fracture into large floating panels. When light winds blew across the playa, these ice panels, sometimes thousands of feet across but only a few millimeters thick, would drift slowly across the water, pushing against any rocks in their path. The rocks weren't being blown by wind directly, nor were they embedded in thick ice that floated them across the playa. Instead, they were being nudged by vast but extremely thin sheets of ice, pushed by breezes that wouldn't normally be strong enough to move the rocks on their own. This explained the parallel tracks. Multiple rocks were being pushed by the same ice sheet. It explained the synchronized turns. When the ice sheet rotated or changed direction, all the rocks it was pushing changed direction together. It explained why no one had seen it happen. The specific combination of rain, freezing temperatures, morning thaw, and wind occurred very rarely, perhaps only a few times per decade in some periods. What makes this solution particularly beautiful is how it demonstrates that unusual phenomena don't always require unusual explanations. The sailing stones weren't moved by mysterious energy fields or exotic physics. They were moved by ordinary ice, ordinary wind, and ordinary rocks interacting in a combination that happened to be very rare. The mystery existed not because the physics were strange, but because the right conditions came together so infrequently that catching them in action required enormous patience and a bit of luck. The research also revealed something slightly melancholy about these stone travelers. Statistical analysis of rock movements over the decades suggests they've become less frequent in recent times compared to the mid-20th century, likely due to drier winters and warmer winter nights associated with climate change. The very conditions that create the sailing stones phenomenon may be occurring less often, meaning future generations might have even fewer opportunities to witness these natural wonders in motion. There's something deeply satisfying about the sailing stones as a mystery. Unlike some unexplained phenomena that frustrate because they can't be observed or measured, the sailing stones left obvious evidence of their movement. The trails were right there, etched into the ground, waiting for patient observers to decipher their message. The solution required no revolutionary new physics, no exotic particles or forces, just careful observation and a willingness to wait for the right moment. The researchers' success demonstrates the power of long-term, patient scientific observation. They didn't try to force an answer through a single intensive investigation. They set up their instruments and waited, trusting that eventually nature would reveal its process. When it did, they were ready to record it, to measure it, to understand it completely. This approach to science, calm and unhurried, stands in contrast to our often frantic modern pace. It's a reminder that some questions can only be answered by those willing to wait. As you relax into sleep, picture racetrack playa on a winter morning. A shallow pond has formed from recent rain, its surface frozen overnight into a thin sheet of ice. As the sun rises, the ice begins to crack with soft pops and crackles. A light breeze, gentle enough that you'd barely notice it on your cheek, begins to push against these massive ice sheets. Slowly, almost imperceptibly, a 700-pound rock begins to slide, pushed by ice so thin you could punch through it with your hand, yet so vast it harnesses the wind's gentle force into motion powerful enough to move stone. The rock glides forward at about the speed a baby crawls, carving a furrow in the soft mud beneath the water. In a few hours, the ice will melt completely, the water will evaporate, and the playa will return to its usual dry state. The rock will sit motionless again, perhaps for another decade, silent and patient, waiting for the next rare alignment of rain, cold, and wind. Lights in the sky that science embraces. Not all mysteries remain unexplained forever, and perhaps the most comforting category consists of phenomena once thought impossible that science eventually embraced and understood. Red sprites stand as a perfect example. For decades, pilots reported seeing brief flashes of red light above thunderstorms, often accompanied by descriptions of jellyfish-like shapes extending high into the upper atmosphere. For years, scientists dismissed these reports as optical illusions or mistakes. The physics didn't seem to support the existence of electrical discharges that far above storm clouds. Then, in the late 20th century, specialized cameras finally captured these elusive lights. Red sprites are real, enormous electrical discharges that occur between 30 and 55 miles above thunderstorms, far higher than ordinary lightning. They last only milliseconds but can extend over vast areas, sometimes spanning dozens of miles across. Their reddish color comes from the interaction of electricity with the thin air at those altitudes, exciting nitrogen molecules in ways that produce distinctive colored light. Once confirmed, sprites became a legitimate field of study, with researchers now understanding them as an important part of Earth's electrical circuit, coupling the atmosphere and ionosphere in ways we're still working to fully characterize. Blue jets represent another example of this pattern. These narrow cones of blue light shoot upward from the tops of thunderclouds, reaching altitudes of 25 to 30 miles above sea level. Like sprites, they were reported by pilots long before scientists accepted their existence. Unlike sprites, which appear to be associated with particularly powerful positive lightning strikes, blue jets seem to occur during the early stages of thunderstorm development and are thought to be triggered by the buildup of charge in the upper portions of storm clouds. The physics of these phenomena reveals a whole layer of atmospheric electricity we never knew existed. Thunderstorms do more than create the ground-to-cloud lightning we see during storms. They participate in a global electrical circuit, maintaining Earth's ionosphere through constant electrical activity. Sprites and blue jets represent upward electrical discharge, the counterpart to the downward strokes of ordinary lightning. Together, these phenomena help transport charge from the lower atmosphere to the ionosphere, contributing to the planet's electrical balance. What's particularly fascinating is that until we had the right cameras looking at the right wavelengths at the right times, we simply couldn't see these phenomena despite them happening thousands of times every night around the globe. They weren't rare or particularly unusual. They were simply outside the range of what our eyes and earlier instruments could detect from the ground. This revelation raises an intriguing question. What other atmospheric phenomena might exist, happening routinely but remaining invisible to us because we haven't yet pointed the right instruments in the right directions? Noctilucent clouds represent another category of mysterious atmospheric lights, though in this case the mystery isn't whether they exist but rather why their behavior has been changing. These clouds form at the edge of space, about 50 miles up, far higher than any weather clouds. They consist of ice crystals forming on tiny particles in the extremely thin air at that altitude. The clouds are so high that after sunset, when the ground is in darkness, they still catch sunlight, glowing with an eerie blue-white luminescence against the darkening sky. Records of noctilucent clouds only go back to the mid-1800s, with the first reported observations appearing shortly after the 1883 eruption of Krakatoa. Some researchers initially thought they might be a result of volcanic material in the upper atmosphere. However, the clouds persisted long after any volcanic effects would have dissipated, suggesting they were a natural phenomenon that had either been overlooked before or had genuinely started appearing more frequently in the late 19th century. Recent research shows that noctilucent clouds are becoming brighter, more frequent, and visible at lower latitudes than in the past. They used to be confined to polar regions, visible only during summer months at latitudes above 50 degrees. Now they're occasionally spotted as far south as Colorado and Utah, extending far beyond their historical range. Scientists link this expansion to climate change. As greenhouse gases warm the lower atmosphere, they paradoxically cause the upper atmosphere to cool. This cooling allows more water vapor to condense into ice at the mesosphere's altitude, creating more and brighter noctilucent clouds. The particles on which these ice crystals form present their own mystery. At the altitude where noctilucent clouds exist, particles are rare. Some come from meteors burning up in the atmosphere. Others might be volcanic aerosols that have been lofted to extraordinary heights. Recent research suggests that particles from rocket launches might also be contributing, with the number of ice crystals per cloud potentially having increased due to the growing number of space launches. Each rocket launch deposits water and other materials into the upper atmosphere, potentially seeding more noctilucent cloud formation. There's something hauntingly beautiful about noctilucent clouds. They glow against the deep blue of twilight, their silvery blue wisps resembling ocean waves frozen in the sky. They mark the boundary between Earth's atmosphere and the beginning of space. Ice crystals surviving in an environment so hostile that air molecules are separated by distances vast compared to their size. They're a visible marker of climate change, a phenomenon becoming more prominent as our atmosphere's temperature structure shifts. Yet they remain breathtakingly beautiful, a reminder that even the consequences of environmental change can manifest in ways that inspire wonder. Another atmospheric mystery that has graduated from unexplained to understood is St. Elmo's fire, though it retains all its visual drama even after explanation. This phenomenon appears as a blue or violet glow around pointed objects during thunderstorms, particularly ship masts, aircraft wingtips, church spires, or mountain peaks. Sailors have observed St. Elmo's fire for centuries, often interpreting it as a protective omen from their patron saint. The fire appears suddenly, creates a gentle hissing or crackling sound and can persist for minutes before fading away. The explanation involves the ionization of air molecules. During thunderstorms, powerful electric fields build up between the clouds and the ground. When these fields become strong enough, they can cause air molecules around pointed objects to ionize, stripping electrons from atoms and creating a plasma. This plasma glows with the characteristic blue-violet light, particularly bright around the sharp points where the electric field is most concentrated. The phenomenon is harmless, though its appearance often signals that conditions are right for lightning, making it a warning sign sailors learn to respect. What's remarkable about St. Elmo's fire is how it connects to other electrical phenomena. The same physics that creates St. Elmo's fire around ship masts also creates the glow sometimes visible around power lines during foggy conditions, known as corona discharge. It's related to the mechanism that creates lightning rod's protective effect, the same principle of charge concentration around pointed conductors. Understanding St. Elmo's fire helped scientists understand Earth's electrical environment better, revealing how charge flows between the atmosphere and ground through multiple mechanisms, not just dramatic lightning bolts. The mystery of earthquake lights represents a phenomenon still in transition from unexplained to understood. For centuries, people have reported seeing lights in the sky before, during, or after earthquakes. Descriptions vary widely. Some report ball-like lights floating through the air. Others see broad auroral displays. Still others describe brief flashes or flames appearing to emerge from the ground. Because earthquake lights are rare and unpredictable, and because earthquakes themselves are dangerous events that understandably capture observers' full attention, gathering reliable data has been challenging. Recent research suggests several mechanisms might be at work. One theory proposes that certain rock types, particularly basalt and gabbro, generate electrical charges when subjected to the immense stress of seismic activity. These charges could migrate to the surface and ionize air molecules, creating visible lights. Another mechanism might involve the piezoelectric effect, where mechanical stress on certain crystals generates electricity. The friction between rock surfaces during seismic motion could create triboelectric charging, similar to the static electricity generated when you rub a balloon on your hair. A 2014 study analyzed reports of earthquake lights from 1600 to the present, compiling 65 documented cases. The analysis revealed that earthquake lights are most commonly associated with rift environments where tectonic plates are pulling apart, and they tend to occur before or during earthquakes rather than afterward. This temporal pattern suggests the lights might be generated by the stress buildup that precedes seismic activity rather than by the earthquake motion itself, potentially giving them some predictive value, though much more research is needed before they could be considered reliable precursors. The study of earthquake lights demonstrates science at work on a difficult problem. The phenomenon is real. Too many credible observers have reported it, and photographic evidence exists from several events. But understanding the mechanism requires piecing together clues from geology, atmospheric physics, and electrical engineering, complicated by the rarity and unpredictability of the events. Each earthquake that produces visible lights provides a new data point, gradually building the foundation for a comprehensive theory. This slow accumulation of understanding represents the typical path for explaining natural phenomena that are rare, brief, and difficult to study in controlled conditions. As you settle into sleep tonight, think about these atmospheric mysteries, phenomena that exist at the boundaries of Earth and space, at the edge of what our eyes can see, in conditions too extreme or too rare for easy study. Consider how many of them were once dismissed as impossible, reported by reliable witnesses but rejected by scientists who couldn't imagine the mechanisms that would allow them. Then think about how patient observation and new technology gradually brought these phenomena into the realm of the understood, proving that the universe is consistently stranger and more interesting than our theories initially suggest. The progression from mystery to understanding doesn't diminish wonder. Red sprites are no less beautiful for being explained. Noctilucent clouds remain breathtaking even though we understand the physics of their formation. St. Elmo's fire still inspires awe when it appears dancing around ship masts or aircraft wings. If anything, understanding enhances appreciation, revealing the elegant simplicity of natural laws operating in extreme conditions to create these visual spectacles. The universe doesn't need to be mysterious to be wonderful. It just needs to be itself, following its physical laws wherever they lead, occasionally producing phenomena so striking that they stop us in our tracks and force us to look up in wonder. The intelligence of swarms. Among the most mesmerizing mysteries of the natural world are those involving the collective behavior of creatures operating as coordinated units despite having no central command. Murmurations of starlings create one of nature's most hypnotic spectacles. Thousands or even millions of birds move together in flowing, shape-shifting formations, turning and diving in perfect synchrony, creating patterns that seem choreographed by some invisible conductor. Yet no bird leads, no bird commands. Each individual follows simple rules based on the positions and movements of its nearest neighbors, and from these simple interactions emerges breathtaking complexity. The mathematics of this phenomenon reveals that each starling pays attention to approximately 6 or 7 of its closest neighbors, adjusting its position and velocity to maintain cohesion with this small group. The result cascades through the entire flock, creating coordinated movement that can shift direction in a fraction of a second, with information propagating through the mass of birds far faster than any individual bird flies. When a predator attacks, the response ripples through the murmuration like a wave, creating a confusion effect that makes it nearly impossible for the predator to focus on any single bird. Recent research using high-speed cameras and sophisticated computer analysis has revealed the precise mechanics of these murmurations. Scientists at the Institute for Complex Systems in Rome filmed starling flocks using multiple cameras positioned to capture three-dimensional data. Their analysis showed that the interactions between birds create what physicists call scale-free correlation, meaning that the bird's behavior is influenced by both nearest neighbors and by birds much farther away in the flock. This creates a system that can respond rapidly to threats while maintaining overall cohesion, balancing local interactions with global coordination in ways that still challenge our understanding of collective dynamics. The mystery deepens when you consider that this behavior serves clear survival functions. Murmurations typically occur as starlings gather at roosting sites during twilight hours. The coordinated flight patterns confuse aerial predators, particularly hawks and falcons that hunt by targeting individual birds. The constant, flowing motion makes it nearly impossible for a predator to lock onto a specific target. Additionally, the roosting sites provide safety in numbers through the night. But while we understand the evolutionary advantages, the precise mechanisms by which birds process information and coordinate with neighbors on timescales of milliseconds remain areas of active research. Swarm intelligence extends far beyond birds. Ants coordinate complex construction projects, maintain supply chains to food sources, and allocate colony resources without any central planning. No ant understands the overall picture of what the colony is building or doing. Each follows simple rules, responds to local chemical signals, and from millions of these simple interactions emerges colony behavior that appears purposeful and intelligent. Ant colonies solve complex optimization problems, finding efficient paths between nest and food sources, allocating workers to different tasks based on colony needs, even conducting what appears to be agriculture by cultivating fungus gardens. The mystery lies not just in how these systems work, but in how they evolved. Natural selection acts on individual organisms, favoring those whose traits help them survive and reproduce. Yet swarm behavior benefits the group, often at potential cost to individuals. Birds on the edge of a murmuration are at greater risk from predators than those in the center. How did selection favor the simple rules that create murmurations when following those rules might increase an individual's danger? The answer involves multi-level selection, game theory, and kinship relationships, creating evolutionary explanations that are mathematically sophisticated yet remain incomplete in some aspects. Fish schools represent another manifestation of swarm intelligence. Thousands of fish move together as a coordinated mass, turning simultaneously, creating the appearance of a single organism. Like murmurations, fish schools provide protection through confusion of predators. But fish add another dimension. They can coordinate not just in air, but in the three-dimensional medium of water, creating spiral formations, sphere-shaped shoals, or streaming rivers of silver bodies, all moving in precise synchrony. The mechanisms fish use involve their lateral line system, a sensory organ that detects water pressure changes from nearby fish, allowing them to maintain exact spacing and coordinate movements even in murky water where vision is limited. One of the most mysterious aspects of swarm behavior is how it starts and stops. A murmuration can suddenly coalesce from birds that were flying individually, forming up into a coordinated mass within seconds. It can dissolve just as quickly, with birds peeling off to perch for the night. The triggers for these transitions aren't fully understood. While predator presence certainly influences behavior, murmurations often form in the absence of obvious threats, suggesting other factors like social bonding, information exchange, or even play might be involved. Researchers studying locust swarms have uncovered fascinating insights into how isolated individuals transform into coordinated swarms. Locusts typically exist in a solitary phase, avoiding other locusts and behaving like typical grasshoppers. Under certain conditions, particularly when food becomes scarce and population density increases, they undergo a dramatic transformation into their gregarious phase, changing both physiologically and behaviorally. In this phase, they seek out other locusts and move in coordinated masses that can contain billions of individuals and travel over 100 miles in a day, devastating crops across entire regions. The transformation involves changes in serotonin levels in the locust brain. When locusts are crowded together, the frequent physical contact triggers increased serotonin production, which flips a switch in their behavior from solitary to gregarious. This single neurotransmitter change cascades into comprehensive physiological and behavioral transformation, demonstrating how simple biochemical mechanisms can underlie complex collective phenomena. Understanding this mechanism has implications for predicting and potentially preventing locust plagues, though the mystery of how to effectively manage these swarms remains largely unsolved. The study of swarm intelligence has inspired new approaches in robotics and computer science. Engineers build robots that follow simple rules similar to those used by birds and fish, creating swarms of small machines that can explore disaster sites, sweep for mines, or even construct structures through collective action. The algorithms that emerge from studying natural swarms solve optimization problems in telecommunications, transportation logistics, and resource allocation. The mystery of how birds, fish, and insects achieve their remarkable coordination has become a source of solutions for human technological challenges. What makes swarm phenomena particularly soothing as mysteries is their accessibility. You don't need specialized equipment to witness a murmuration. You just need to be in the right place at the right time, typically near a starling roosting site during autumn or winter evenings. The experience is democratic, available to anyone willing to look up at the right moment. And when you witness it, you're seeing something that science has studied extensively yet can't fully replicate. A natural phenomenon that follows physical laws but creates something that feels almost magical in its coordinated beauty. As you drift towards sleep, imagine yourself standing beneath a murmuration. The sky fills with thousands of starlings, their collective form expanding and contracting like a breathing organism. The shapes they create have no names because they exist only briefly before flowing into new configurations. You watch birds on one edge suddenly turn, and that turn propagates across the entire flock in a wave that moves faster than any individual bird. The sight is hypnotic, the sound a rushing whisper of thousands of wings cutting air in near-perfect unison. No conductor directs this symphony. No leader guides this dance. Yet the coordination is perfect, the beauty absolute, emerging from nothing more than individuals following simple rules, responding to neighbors, creating complexity from simplicity, order from potential chaos, art from algorithm. The songs of giants. The ocean conceals many mysteries, but few are as profound and moving as the songs of whales. Humpback whales produce complex vocalizations that can last up to 20 minutes, which they repeat for hours without pause. These songs feature hierarchical structure. Individual sounds combine into phrases, phrases group into themes, and themes organize into complete songs. Each whale population has its own song that changes gradually over months and years, with all males in a population singing essentially the same version at any given time. How they coordinate these changes across hundreds of miles of open ocean remains mysterious. What's particularly striking is that humpback whale songs aren't static. They evolve. New elements appear, old ones drop out, and the entire song can transform completely over a few years. Even more mysteriously, songs from one whale population can spread to other populations thousands of miles away. Songs originating off the coast of Australia have been documented spreading across the South Pacific, reaching French Polynesia approximately 2 years later, then continuing to the waters off Ecuador, as if carried by an invisible cultural transmission network spanning the entire Pacific Ocean. This represents one of the largest documented cases of cultural transmission in any non-human species. The songs serve multiple purposes. They attract mates, they assert dominance, they may communicate information about location and resources. But the evolutionary pressure that favors constantly changing songs, rather than maintaining a stable signal, remains puzzling. Why should females prefer males singing novel songs rather than traditional ones? Why should males invest energy in learning and propagating changes rather than perfecting a time-tested version? These questions touch on fundamental mysteries of sexual selection, cultural evolution, and the nature of creativity itself. Blue whales, the largest animals ever to live on Earth, produce sounds at frequencies so low humans can barely hear them, mostly below the range of human hearing in the infrasonic realm. These calls can travel thousands of miles through ocean water, making blue whales potentially capable of communicating across entire ocean basins. During the Cold War, the U.S. Navy's SOSUS network, designed to track Soviet submarines, inadvertently created the most comprehensive marine mammal listening network ever deployed. Analysis of decades of SOSUS recordings revealed the extent of blue whale vocal behavior, showing they call continuously throughout their range, maintaining what amounts to a planet-spanning conversation. Yet there's a mystery embedded in these magnificent songs. Blue whale calls have been getting progressively deeper over the past several decades. Recordings show that the fundamental frequency of blue whale vocalizations has decreased by several hertz since the 1960s. Researchers have proposed various explanations. Perhaps the recovery of whale populations from near extinction means whales don't need to call as loudly to be heard by potential mates, allowing them to use lower, less energetically expensive frequencies. Or perhaps changes in ocean chemistry from increasing carbon dioxide absorption alter sound propagation properties, prompting whales to adjust their calls. Another theory suggests that increased ocean noise from shipping forces whales to lower their frequencies to avoid the frequency band where ship noise is loudest. The truth is we don't fully understand why whale songs change, whether in frequency among blues or in structure among humpbacks. What we do know is that these changes represent a form of culture, learned behavior passed between individuals and across generations. Young male humpbacks learn songs from older males, memorizing complex sequences that can last 20 minutes and involve hierarchies of sounds, phrases, and themes. The fact that an entirely new song can spread across an ocean basin over the course of a few years suggests these creatures possess sophisticated learning abilities and some form of social network through which information propagates. Sperm whales add another layer to the mystery of cetacean communication. These deep-diving giants produce loud clicks that they use for echolocation, but they also create pattern sequences called codas, click patterns that appear to have specific social functions. Different sperm whale clans use different codas, like dialects in human languages. Whales from one region of the ocean might produce predominantly 3-click or 4-click codas, while whales from another region favor different patterns. These dialects are learned, not inherited genetically, representing another example of non-human culture maintained across generations through social learning. The mystery deepens when you consider that sperm whales have the largest brains of any animal on Earth, weighing up to 20 pounds and containing far more neocortex than humans possess. What goes on in those enormous brains as whales dive thousands of feet into the dark? hunting giant squid in the abyss? What information do they encode in their codas? What social bonds do they maintain across years of swimming together? We've barely begun to understand the complexity of their social lives, their communication systems, their cognitive capabilities. Perhaps the most moving aspect of whale song mysteries is their accessibility to our emotions, even when they elude our understanding. You can listen to humpback whale songs online, recordings that capture these haunting vocalizations echoing through the ocean. Even without understanding what they mean, you can hear something profound in them, some expression of consciousness and experience that transcends species boundaries. These songs remind us that we share our planet with other minds, other forms of awareness that evolved along completely different paths yet arrived at something we recognize as purposeful communication, as art perhaps, as culture certainly. As you settle deeper into rest tonight, imagine the ocean at this moment, filled with whale songs traveling through the darkness. A humpback off the coast of Hawaii sings his complex melody, which will gradually spread across the Pacific over the coming years. A blue whale in the Southern Ocean produces its deep, rumbling call, which propagates for thousands of miles, potentially reaching the ears of whales swimming off the coast of South America. Sperm whales dive into the abyss, clicking and calling to each other in patterns their families have used for generations, maintaining social bonds through sound in an environment too dark and vast for any other form of communication to work effectively. The ocean is never silent, never empty of communication, never without its singers and their mysterious songs. Circles in the sand. In the vast expanse of the Namib Desert, one of the oldest and driest deserts on Earth, a peculiar phenomenon appears across hundreds of miles of arid grassland. Scattered throughout the landscape are circular patches of bare sand, ranging from about 6 to 35 feet in diameter, each surrounded by a ring of tall grass. These formations, known as fairy circles, create a polka dot pattern so regular and extensive that it's visible from aircraft flying overhead. For decades, they've puzzled scientists and inspired wonder in anyone who encounters them. The local Himba people have their own explanations for these mysterious circles. According to their traditional beliefs, the circles are the footprints of their god Mukuru, marks left by the divine as it walked across the desert. Other stories suggest the circles mark places where dragons exhale poisonous breath from beneath the earth, killing all vegetation. Modern tour guides sometimes share these stories with visitors, acknowledging that while science seeks mechanical explanations, there's something undeniably mysterious about these formations that invites mythological interpretation. The scientific investigation of fairy circles has been ongoing since they were first formally described in the 1970s, though they've certainly existed far longer. Early theories focused on various potential causes. Some researchers suggested that toxic plants created bare patches where they once grew, their roots leaving behind chemicals that prevented other plants from establishing. Others wondered whether underground gas venting might kill vegetation in circular patterns. As more data accumulated, two main competing theories emerged, each supported by research and each hotly debated within the scientific community. The termite hypothesis proposed that sand termites created the circles by consuming grass roots in systematic patterns. The idea had intuitive appeal. Termites are known ecosystem engineers in many environments, capable of dramatically altering landscapes through their activity. Proponents of this theory pointed to the presence of termite activity in some fairy circles and suggested that the termites were harvesting grass and creating water reservoirs in the process. The bare circles would collect water from rain, storing it beneath the surface where termite colonies could access it during dry periods, while the surrounding grass ring would benefit from water seeping outward from the reservoir. The competing theories suggested that fairy circles arise from vegetation self-organization, a process in which plants automatically arrange themselves into regular patterns through competition for scarce water resources. According to this explanation, in environments where water is severely limited, plants that are too close together compete intensely for the same water resources, leading to the death of plants in the center. Meanwhile, plants at the edges of these bare patches benefit from water that would have been consumed by now-dead central plants, allowing them to grow more vigorously and create the characteristic rings of tall grass. This process would naturally generate regularly spaced circular patterns through what's called scale-dependent feedback, a mathematical principle that generates periodic patterns in systems with local competition and long-range facilitation. The debate between these theories grew heated, with studies published supporting each viewpoint and critiquing the other. Some research found fairy circles without significant termite presence, undermining the termite hypothesis. Other studies documented termite activity at many fairy circles, supporting that theory. The controversy exemplified how scientific mysteries can persist not from lack of investigation, but from the genuine difficulty of determining causation in complex ecological systems where multiple factors interact. Recent work has begun to suggest that the answer might not be either-or, but rather both, and a comprehensive study published in the journal Nature in 2017 proposed that fairy circles might result from the combined effects of both mechanisms. Termite activity creates larger-scale patterns based on the spacing of termite colonies competing for territory, while plant self-organization creates smaller-scale patterns between the termite territories. The interaction of these two processes operating at different scales could generate the complex patterns observed in the field, patterns that neither mechanism alone could fully explain. More recent research has added additional layers to our understanding. Studies monitoring soil moisture around fairy circles have shown that the bare patches indeed act as water catchments. After rain falls, water infiltrates the sandy soil within the circles more efficiently than in grass-covered areas, creating underground reservoirs. This water then moves outward through the soil, feeding the grasses at the circle's edges. The grasses, in turn, have denser, more extensive root systems that make the soil more porous, allowing even more water to infiltrate, creating a positive feedback loop that maintains the pattern. Investigations of soil communities have revealed yet another factor. The bare centers of fairy circles have dramatically different underground ecosystems than the grass rings. Soil nematodes, microscopic worms that play crucial roles in soil food webs, are far less abundant in circle centers than in surrounding areas. Without these key organisms breaking down organic matter and cycling nutrients, the soil in circle centers becomes hostile to plant establishment. Even if seeds land in the circles and germinate after rain, the seedlings struggle to survive without the soil ecosystem support available outside the circles. This helps explain why fairy circles persist for decades. Once established, the degraded soil ecology in the circle centers reinforces the pattern, making it difficult for vegetation to recolonize even when water is available. The discovery of fairy circles in Western Australia in 2014 provided an unexpected opportunity for comparative research. Here, thousands of miles from Namibia, in a completely different ecosystem with different plant and animal species, nearly identical circular patterns appeared in arid grasslands. The Australian fairy circles showed the same regular spacing, the same size ranges, the same patterns of bare centers surrounded by grass rings. Importantly, the dominant termite species in Australia differ from those in Namibia, and some Australian fairy circles occur in areas with minimal termite activity. This finding strengthened the vegetation self-organization theory, suggesting that these patterns represent a universal response of arid grassland ecosystems to water stress, emerging naturally from the mathematics of plant competition regardless of the specific species involved. The mathematical elegance of vegetation self-organization connects fairy circles to a broader family of natural patterns known as Turing patterns, named after mathematician and computer science pioneer Alan Turing. In a famous 1952 paper, Turing showed how simple chemical reactions that both activate and inhibit each other could spontaneously generate regular patterns, providing a mathematical foundation for understanding pattern formation in nature. His ideas have since been applied to explain stripe patterns on zebras, spot patterns on leopards, ridge patterns on sand dunes, and countless other natural phenomena. Fairy circles may represent another manifestation of these fundamental mathematical principles, showing how local competition and longer-range facilitation can generate remarkable spatial regularity from initially random distributions. There's something deeply satisfying about fairy circles as a mystery. They're visible, obvious, regular enough to demand explanation, yet complex enough to resist simple answers. They exist at the intersection of multiple scientific disciplines: ecology, soil science, mathematics, hydrology, even entomology. Understanding them requires integrating knowledge from all these fields, recognizing that natural phenomena often arise from the interaction of multiple causes operating at different scales. The progression of scientific understanding from single competing theories to integrated multi-causal explanations reflects how science often works. Early stages emphasize differences between theories, but mature understanding reveals how apparently contradictory explanations can both be partially correct, each describing different aspects or scales of the same complex phenomenon. As you drift towards sleep, picture the Namib Desert from above, its red sand dotted with thousands upon thousands of fairy circles, each one a small ecosystem unto itself, each one the product of plants competing for scarce water, termites engineering their environment, and soil organisms creating feedback loops that maintain patterns across decades. Imagine rain falling on this ancient landscape, soaking into the sandy circles, feeding the roots of grasses at the edges, allowing this intricate pattern to persist for another season. The fairy circles remind us that mystery and understanding aren't opposites but rather points along a continuum, that the more we learn about natural phenomena, the more layers of complexity and beauty we discover, that solving a mystery often reveals deeper mysteries waiting beneath the surface. The quantum realm where rules break down. As we descend from the scale of landscapes and organisms to the realm of atoms and particles, we encounter mysteries of a fundamentally different character. Quantum mechanics, the physics governing the smallest scales of reality, presents phenomena so counterintuitive that even the physicists who developed the theory never fully accepted all its implications. Albert Einstein spent much of his later career trying to prove that quantum mechanics must be incomplete, that beneath its statistical predictions must lie a deterministic reality we simply haven't yet discovered. He was wrong, but his discomfort with quantum mechanics was understandable. Quantum entanglement stands as perhaps the most unsettling feature of quantum reality. When two particles interact in certain ways, they can become entangled, their properties linked such that measuring one particle instantly determines the state of the other, regardless of the distance separating them. Einstein famously called this spooky action at a distance, arguing that it violated the principle of locality, the idea that objects are only influenced by their immediate surroundings, and that no influence can travel faster than light. For decades, the reality of entanglement remained debated. Einstein and his colleagues Boris Podolsky and Nathan Rosen proposed in 1935 that quantum mechanics must be incomplete, that hidden variables must exist to explain the apparent correlation between entangled particles without requiring any faster-than-light influence. It seemed impossible that measuring a particle here could instantaneously affect a particle thousands of miles away. There had to be some underlying classical reality that quantum mechanics was failing to describe. The breakthrough came in 1964 when physicist John Bell demonstrated mathematically how to test whether hidden variables could explain quantum correlations. His inequality provided a specific prediction. If local hidden variable theories were correct, correlations between measurements on entangled particles would have to fall below a certain limit. But quantum mechanics predicted that entanglements would violate this limit, producing stronger correlations than any classical theory could explain. The stage was set for definitive experimental tests. The first test came in 1972 when John Clauser and Stuart Friedman conducted a groundbreaking experiment at the University of California, Berkeley. They created pairs of entangled photons and measured their polarizations at different angles. Their results clearly violated Bell's inequality, supporting quantum mechanics predictions. However, skeptics noted potential loopholes. Perhaps the detection equipment wasn't efficient enough, or perhaps the measurement settings were somehow communicating with each other, or perhaps the choice of which measurement to make wasn't truly random. Over the following decades, increasingly sophisticated experiments closed these loopholes one by one. In the 1980s, Alain Aspect at the University of Paris conducted experiments where the measurement settings switched so rapidly that no light-speed signal could travel between them, closing the locality loophole. In more recent years, experiments achieved detection efficiencies high enough to close the detection loophole. By 2015, multiple research groups conducted what they called loophole-free Bell tests, experiments that closed all major loopholes simultaneously, providing the strongest possible evidence that quantum entanglement is real and cannot be explained by any local hidden variable theory. The implications are staggering. Two particles that have interacted and become entangled remain connected in a way that transcends space. Not in the sense that information travels between them faster than light, because the correlations can't be used to send messages and thus don't violate relativity. Rather, the particles seem to share a single quantum state that isn't localized to either particle individually. Measuring one particle doesn't send a signal to the other. Instead, the measurement reveals information about a shared state that existed between them all along, even though that state wasn't determined until the measurement occurred. Even more remarkably, experiments in recent years have pushed the mystery deeper. Researchers have used light from distant quasars to determine measurement settings in entanglement experiments. One experiment used light from quasars whose photons began their journey toward Earth 7.8 billion and 12.2 billion years ago, respectively. These ancient photons determined which measurements to make on entangled particles created in a laboratory. The results still showed quantum correlations, still violated Bell's inequality. If some hidden variable explanation exists, it would have needed to be set in motion billions of years before Earth even formed, long before the experiments were conceived, effectively requiring that the universe predetermine these measurement outcomes at the dawn of time. Few physicists find this predetermined universe explanation satisfying. Instead, the consensus has shifted to accepting that quantum entanglement is real, that the universe at its most fundamental level doesn't consist of independent objects with definite properties, but rather of interconnected quantum states that only resolve into definite properties when measured. The universe is genuinely probabilistic, not just apparently so due to our ignorance of hidden variables. The 2022 Nobel Prize in Physics was awarded to Alain Aspect, John Clauser, and Anton Zeilinger for their experimental work demonstrating quantum entanglement and pioneering quantum information science. Their decades of careful experimentation transformed entanglement from a philosophical puzzle into a confirmed feature of reality and a practical resource for technology. Quantum cryptography now uses entanglement to create communication channels that cannot be intercepted without detection. Quantum computers leverage entanglement to perform certain calculations that would be impossible for classical computers. What Einstein considered a flaw in quantum mechanics has become a foundation for new technologies. Yet mysteries remain. We still don't understand why measurement causes entangled particles to suddenly resolve into definite states. This is called the measurement problem, and despite nearly a century of quantum mechanics, we still lack consensus on what it means. Different interpretations of quantum mechanics, from the Copenhagen interpretation to many worlds to decoherence-based approaches, offer different frameworks for understanding measurement, but none provides a complete, universally accepted answer. Recently, experiments have even demonstrated quantum entanglement at the highest energies ever achieved. At the Large Hadron Collider, physicists observed entanglement between top quarks, the heaviest known fundamental particles, produced in collisions at energies of 13 trillion electron volts. The fact that entanglement persists even in these extreme conditions, at energy scales far beyond anything that exists naturally in the universe today, demonstrates that quantum mechanics governs reality at all known scales, from the coldest, most delicate atomic systems to the most energetic particle collisions we can create. Another recent discovery challenges our understanding of what creates quantum correlations. A 2025 experiment showed that photons that are not entangled can still exhibit quantum correlations that violate Bell's inequality under certain conditions. The key lies in quantum indistinguishability, situations where it's fundamentally impossible to determine which source produced which photon. This phenomenon suggests that entanglement might not be the only quantum property that produces non-local correlations, hinting at deeper principles underlying quantum behavior that we're only beginning to explore. The beauty of quantum mysteries is that they force us to abandon our classical intuitions about how reality works. We're compelled to accept that nature operates according to principles that feel alien to our everyday experience, principles that seem more like mathematics than like the physical world we perceive. Yet these principles are real, confirmed by countless experiments, and they govern everything from the structure of atoms to the behavior of materials to the functioning of the sun. Quantum mechanics isn't a strange exception to normal physics. It's the fundamental physics, and what we call normal is an approximation that emerges when we zoom out to larger scales where quantum effects average away. As you relax into sleep, consider that at the quantum level, reality is doing something genuinely strange at every moment. Particles are entangled across vast distances, sharing states that don't exist in either location individually but only in the relationship between them. Atoms exist in superpositions of multiple states until measurement forces them to choose. The very fabric of reality at its smallest scales is probabilistic, indeterminate, woven from mathematical relationships rather than definite properties. Yet from this strange quantum foundation emerges the solid, dependable classical world we inhabit, where objects have definite locations, where cause precedes effect, where the future isn't written until it unfolds. The emergence of the classical from the quantum remains one of physics' deepest mysteries, a reminder that the universe is more subtle, more mathematical, and more interconnected than our senses suggest. The patterns that math predicts. Nature has a remarkable tendency to create patterns, from the hexagons of beehives to the spirals of seashells to the branching of river deltas. Many of these patterns emerge from simple mathematical principles, showing how complexity can arise from simplicity when physical laws interact with chance over time. Among the most visually striking examples are columnar basalt formations, vast arrays of geometric stone pillars that look almost designed, yet form through purely natural processes. Columnar basalt appears when lava cools slowly and evenly. As the molten rock solidifies, it contracts, creating tension in the hardening material. This tension releases through fracturing, and the fractures naturally organize into hexagonal patterns. Why hexagons? Because that's the most efficient way to divide a plane into equal areas while minimizing the total length of boundaries. Bees use hexagons in their honeycombs for similar mathematical reasons. The cooling basalt doesn't know it's creating hexagons. It simply follows the path of least resistance, and mathematics dictates that path. The Giant's Causeway in Northern Ireland stands as one of the most famous examples, featuring approximately 40,000 interlocking basalt columns rising from the sea. According to legend, the Irish giant Finn Mac Cumhaill built the causeway as stepping stones to Scotland so he could fight his Scottish rival Bonandener. The reality is no less impressive. Around 50 to 60 million years ago, volcanic eruptions created a massive lava plateau. As the lava cooled, it fractured into the pillars we see today, some reaching up to 12 meters high, most forming nearly perfect hexagons. Similar formations appear around the world wherever volcanic activity and slow cooling coincide. The Devil's Postpile in California, the Fingal's Cave in Scotland, the basalt formations of Iceland, all demonstrate the same mathematical principles at work. Each column represents a cooling center where contraction stress concentrated and fractures propagated. The regular spacing between columns reflects the uniform cooling rate across the lava field. The result is a geometry that looks designed but emerges purely from physics. Another category of natural patterns that exhibits remarkable mathematical regularity is Fibonacci spirals. which appear in countless biological systems. Sunflower seed heads, pine cones, nautilus shells, even the arrangement of leaves around plant stems often follow this sequence. 1, 1, 2, 3, 5, 8, 13, where each number is the sum of the two preceding numbers. This pattern appears because it represents an optimal packing arrangement that maximizes efficiency while allowing for growth. Consider a sunflower. Seeds need to pack densely at the flower center while spreading out as the flower grows. If seeds appeared at regular angular intervals, they'd align in straight rows, creating inefficient gaps. But if each new seed appears at approximately 137.5 degrees from the previous one, a number closely related to the Fibonacci sequence and known as the golden angle, they pack with maximum efficiency, creating the beautiful spiral patterns we observe. The plant doesn't calculate this angle consciously. Evolution has favored this arrangement because it allows sunflowers to produce more seeds in the same space compared to other arrangements. The mathematics underlying these patterns connects to deep principles about optimization and efficiency. Natural selection favors organisms that make efficient use of resources and space. Over millions of years, random variations that happen to align with optimal mathematical solutions survive and reproduce more successfully than those that don't. The result is a living world filled with mathematical elegance, from the hexagons of beehives to the spirals of galaxies. Wave patterns in nature provide another realm where mathematics predicts and explains what we observe. Sand dunes form ripples with remarkably regular spacing, the result of wind patterns interacting with grain size and surface friction. Ocean waves organize into sets and patterns based on the interference of waves coming from different directions and generated by different weather systems. Cloud streets, those long parallel rows of cumulus clouds that sometimes appear, form when rising columns of warm air organize into regular spacing due to atmospheric circulation patterns. Perhaps the most mathematically elegant natural patterns are fractals, shapes that exhibit self-similarity at different scales. Coastlines provide a classic example. Zoom in on any section and you find smaller versions of the same irregular, jagged pattern. Mountains, river networks, tree branches, and even the bronchial passages in our lungs all display fractal characteristics. These patterns arise naturally in systems where similar processes occur at multiple scales. A river delta branches because flowing water carves channels, and this channeling process works the same whether you're looking at major tributaries or tiny streams, creating branching patterns that look similar at every magnification. Mandelbrot, the mathematician who coined the term fractal, recognized that traditional geometry with its perfect circles and straight lines poorly describes natural shapes. Real clouds aren't spheres, mountains aren't cones, coastlines aren't circles. Fractal geometry captures the irregularity and complexity of natural forms through simple iterative rules that generate infinite complexity from finite descriptions. The mathematics of fractals has revolutionized our understanding of everything from fluid turbulence to the growth of cities to the structure of financial markets. The fact that mathematics describes natural patterns so well remains one of science's deepest mysteries. Why should the universe operate according to mathematical principles? Why should equations written on paper predict phenomena we've never observed? Eugene Wigner called this the unreasonable effectiveness of mathematics, noting that mathematical structures developed for purely abstract reasons often turn out to perfectly describe physical phenomena discovered later. The mathematics of non-Euclidean geometry, developed in the 19th century as a theoretical curiosity, became essential for Einstein's theory of gravity decades later. Quantum mechanics relies on mathematical structures so abstract that some were only fully developed decades after physicists began using them. The mystery isn't just that math works, but that often the simplest, most elegant mathematics describes reality. Einstein's field equations for gravity, which describe the curvature of spacetime and predict everything from planetary orbits to black holes to the expansion of the universe, fit on a single line. Schrödinger's equation, which governs all of quantum mechanics and describes the behavior of everything from electrons to molecules to quantum computers, also fits on a single line. The fundamental laws of physics are expressed in mathematics of stunning elegance and simplicity. Yet from these simple laws emerges the immense complexity of the real world. Snowflakes form infinite varieties of intricate six-fold symmetric patterns, each unique, yet all following the same basic physical principles of ice crystal growth. The atmosphere, governed by relatively simple fluid dynamics equations, generates weather patterns so complex they remain fundamentally unpredictable beyond a few days despite our most powerful computers. Living systems, operating according to chemistry and physics, create structures and behaviors of such sophistication that we struggle to fully understand or replicate them. This emergence of complexity from simplicity represents one of science's most profound themes. Reductionism works. If you understand the parts and the rules they follow, you can in principle predict the behavior of the whole. But prediction and understanding are different things. Even if we could calculate every detail of a weather system or an ecosystem or a brain, such calculations wouldn't necessarily give us insight into the patterns and principles that make these systems work. We need both reductive analysis and integrative synthesis, both the equations that describe individual interactions and the broader perspectives that reveal emergent patterns. As you drift deeper into sleep, imagine the mathematical structures underlying visible reality. Picture water molecules, each following simple rules of attraction and repulsion, spontaneously organizing into the hexagonal symmetry of snowflakes. Visualize basalt cooling into perfect geometric columns without any designer or plan, just physics following its inevitable course. Consider seeds arranging themselves in spirals because that arrangement happens to work better than alternatives, favored by selection over countless generations. The universe is both mechanistic and creative, deterministic yet capable of generating endless novelty, following mathematical laws yet producing phenomena that surprise and inspire us. There's no contradiction here, just the recognition that simple rules playing out across vast numbers of interactions and over long spans of time create the rich, complex, mysterious world we inhabit. Lights that dance at the edge of space. Among the most spectacular natural phenomena are auroras, the dancing lights that appear in polar skies when charged particles from the sun interact with Earth's atmosphere and magnetic field. For centuries, people living at high latitudes have watched these ethereal displays, green curtains of light waving across the night sky, sometimes accompanied by reds and purples at higher altitudes, occasionally spreading far enough south that viewers at mid-latitudes can witness them during particularly strong solar storms. The science behind auroras is well understood, yet the phenomenon retains its power to inspire wonder. The sun constantly emits a stream of charged particles called the solar wind, primarily electrons and protons traveling at speeds of several hundred kilometers per second. When these particles reach Earth, our planet's magnetic field deflects most of them, protecting the atmosphere and surface from dangerous radiation. However, near the poles, the magnetic field lines funnel particles down into the upper atmosphere, where they collide with oxygen and nitrogen molecules at altitudes of 100 to 300 kilometers above the surface. These collisions excite the atmospheric molecules, raising their electrons to higher energy states. When the electrons fall back to their normal states, they release energy as light. Oxygen produces green and red emissions, while nitrogen contributes blue and purple hues. The specific colors depend on altitude and the energy of the incoming particles. The most common auroral color is pale green from oxygen at about 100 kilometers altitude. Red auroras, rarer but spectacular, come from oxygen at higher altitudes where the atmosphere is thinner. The blues and purples of nitrogen add variety to the display. What makes each aurora unique is the constantly changing solar wind and Earth's dynamic magnetic field. During quiet solar conditions, auroras remain confined to an oval-shaped region around each magnetic pole, typically only visible from high-latitude locations. But during solar storms, when the sun ejects massive bursts of plasma in events called coronal mass ejections, auroras intensify dramatically and expand toward the equator, sometimes becoming visible from latitudes as low as 40 degrees or even 30 degrees in extreme cases. The most intense auroral displays coincide with peaks in the sun's 11-year activity cycle, though spectacular auroras can occur at any time when a coronal mass ejection happens to be directed toward Earth. The largest solar storm on record, the Carrington event of September 1859, created auroras visible from the Caribbean and lit the sky so brightly that people in the Rocky Mountains reportedly woke up thinking it was dawn. Telegraph systems worldwide sparked and caught fire, operators received electric shocks, and some telegraph systems continued functioning even after being disconnected from their power supplies, powered solely by electrical currents induced by the magnetic storm. If such an event occurred today, it could cause widespread damage to power grids, satellites, and electronic systems. Space weather forecasting has become increasingly important as our technological infrastructure grows more vulnerable to solar storms. Satellites monitor the sun continuously, providing warnings when coronal mass ejections are headed toward Earth, giving power companies and satellite operators time to take protective measures. Despite these precautions, solar storms remain a reminder of our planet's connection to the sun and our vulnerability to space weather. An intriguing mystery connected to auroras involves sounds that some observers claim to hear during displays. Historical accounts and modern reports describe crackling, hissing, or whooshing sounds apparently coinciding with auroral movements. This seems physically impossible. Auroras occur at altitudes of 100 kilometers or more, far too high for sound waves to propagate down to ground level with any significant intensity. Any sounds generated at auroral altitudes would take several minutes to reach the ground and would be greatly attenuated. Yet the reports persist, coming from reliable observers who insist they heard sounds synchronized with visible auroral movements. Recent research suggests a possible explanation. The same electrical disturbances that create auroras might also induce electrical discharges at ground level in certain conditions, particularly around objects with poor electrical conductivity like dry hair, clothing, or even blades of grass. These microdischarges could create faint crackling sounds that observers unconsciously associate with the aurora. The sounds wouldn't actually come from the aurora itself, but from local electrical effects induced by the same space weather that produces the lights. This explanation remains somewhat speculative, requiring more research to definitively confirm, but it demonstrates how mysteries can persist even around well-understood phenomena when secondary effects create observations that don't fit the primary explanation. Beyond Earth, auroras occur on other planets with magnetic fields. Jupiter's auroras are particularly spectacular, hundreds of times more energetic than Earth's, driven by the planet's powerful magnetic field and interactions with its moon Io, which supplies charged particles through its volcanic eruptions. Saturn, Uranus, and Neptune all have auroras, each shaped by the peculiarities of their magnetic fields and atmospheric compositions. Even Mars, which lacks a global magnetic field, experiences localized auroras in regions where ancient crustal magnetism remains. The study of planetary auroras helps scientists understand the general principles of how magnetic fields interact with charged particles and atmospheres. Each planet provides a different combination of variables, different magnetic field strengths and geometries, different atmospheric compositions, different sources of charged particles. By comparing auroral phenomena across the solar system, researchers build comprehensive models of magnetospheric physics applicable not just to planets we can observe but potentially to exoplanets around other stars, where auroras might be detectable through their emission signatures even when the planets themselves are too faint and distant to image directly. There's something particularly soothing about auroras as a phenomenon. Unlike many mysteries that involve rare or hard-to-observe events, auroras are relatively common at high latitudes and can be predicted with reasonable accuracy days in advance. Anyone with the desire and resources to travel to places like Iceland, northern Norway, Alaska, or northern Canada during winter can likely witness an aurora during a week-long visit. The displays are harmless, purely visual, requiring no special equipment to enjoy. They represent one of nature's most accessible spectacles, a reminder that our planet is not isolated in space, but constantly bathed in particles from the sun, protected by an invisible magnetic shield that reveals itself through these glowing curtains of light. As you settle into deeper rest, imagine standing beneath an active aurora. The sky fills with green light, rippling like curtains blowing in a breeze that exists only in the ionosphere 100 kilometers above your head. The curtains brighten and fade, shifting shapes, sometimes stretching from horizon to horizon, sometimes concentrating into bright bands directly overhead. If you're fortunate enough to be somewhere truly dark, far from artificial lights, you might see stars through the thinner parts of the aurora, the Milky Way arching across the sky while the aurora dances in the foreground. The silence is complete except perhaps for the crunch of snow beneath your feet and your own breathing creating small clouds of condensation in the cold air. This is Earth announcing its connection to the sun, its magnetic field made visible through chemistry and physics, a natural light show that's been performing for billions of years and will continue long after humanity has gone. Beauty for its own sake, needing no audience yet generous to any observer who takes the time to look up. The magnetic sense we cannot feel. Among the most mysterious sensory capabilities in the animal kingdom is magnetoreception. the ability to detect Earth's magnetic field and use it for navigation. Many animals possess this sense. Birds use it to navigate during migration. Sea turtles use it to find their way back to nesting beaches. Even lobsters orient themselves using magnetic cues. Yet the mechanism remains incompletely understood, and humans, despite sharing evolutionary ancestry with these animals, apparently lack the ability to consciously sense the magnetic field. The evidence for magnetic sensing in animals is overwhelming. Homing pigeons released hundreds of miles from their loft reliably return home even on overcast days when celestial navigation is impossible. Experiments have shown that attaching magnets to pigeons' heads disrupts their navigation, confirming they use magnetic cues. Sea turtles hatching on beaches immediately swim toward the ocean. Then once at sea, they follow complex migration routes that eventually, years later, bring them back to their birth beaches. They accomplish this navigational feat using a combination of cues, including magnetic field detection that allows them to construct a magnetic map of the ocean and determine their position relative to their destination. Perhaps most remarkably, some birds can perceive the magnetic field's inclination angle, essentially seeing the magnetic field lines and using them like a compass that works even when they can't see the sky. Research suggests that this ability may be based on quantum mechanical effects in specialized proteins in the bird's eyes called cryptochromes. When light hits these proteins, it creates pairs of radicals, molecules with unpaired electrons. These radical pairs can exist in different quantum states, and the Earth's weak magnetic field can influence which states are formed, potentially creating a visual pattern overlaid on the bird's normal vision that shows the direction and intensity of the magnetic field. This quantum biological mechanism, if confirmed, would represent a remarkable example of quantum effects playing a functional role in living systems. Usually, quantum effects are thought to be too delicate to survive in the warm, wet, noisy environment of living cells. But cryptochromes might provide an exception, maintaining quantum coherence long enough for the magnetic field to influence the radical pair states, which then affect chemical reactions that produce signals the bird's brain can interpret. Research continues to test this hypothesis, with experiments showing that magnetic orientation in some birds can be disrupted by radiofrequency electromagnetic fields that would interfere with quantum radical pair mechanisms. An alternative magnetoreception mechanism involves magnetite crystals, tiny particles of magnetic iron oxide found in some animals' bodies. Magnetite is naturally magnetic and can align with external magnetic fields. Some bacteria use chains of magnetite crystals to orient themselves along magnetic field lines, essentially making each cell a microscopic compass. Similar magnetite deposits have been found in various animals including fish, turtles, and birds, suggesting they might use these crystals to detect magnetic fields, though exactly how the crystal movements translate into neural signals remains unclear. Fascinatingly, humans also have magnetite crystals in our brains, leading to speculation that we might have a dormant magnetic sense. Some experiments have suggested that human brain activity responds to changes in magnetic fields, though we don't consciously perceive these responses. Whether this represents a vestigial sense from ancestors who used magnetic navigation or simply an incidental physical interaction without functional significance remains debated. The broader mystery is why magnetic navigation evolved in some species but not others. Many animals that would seemingly benefit from magnetic sensing, such as mammals that migrate long distances, show little evidence of possessing this ability. Meanwhile, animals with much smaller brains, like insects, sometimes demonstrate magnetic sensitivity. Monarch butterflies undertake 1,000-mile migrations using a combination of sun compass orientation and potentially magnetic cues, despite having brains smaller than a pinhead. The butterfly that arrives in Mexico never lived there before. It's following a route encoded in its nervous system, inheriting not a memory of the route, but the ability to navigate it using a combination of genetic programming and environmental cues. The idea that navigational information can be inherited genetically is itself mysterious and wonderful. A butterfly emerges from its chrysalis with no experience of the world, yet somehow knows to fly southwest, using the sun's position and internal circadian rhythms to maintain proper heading, eventually reaching a specific mountain valley it has never seen. The neural circuits and algorithms that make this possible are encoded in its genes, refined over countless generations of natural selection. This means evolution can program not just body structures but also complex behaviors, embedding knowledge of geography and timing into nervous systems through purely genetic mechanisms. Even more mysterious are cases where animals seem to navigate using cues we haven't yet identified. Some fish return to specific streams to spawn, recognizing chemical signatures unique to their birth streams. But in some cases, they accomplish this navigation even when experimental manipulations eliminate all known cues, suggesting additional sensing mechanisms remain undiscovered. Similarly, some migratory birds tested in planetariums where all known navigational cues can be controlled still show orientation preferences that researchers cannot fully explain, hinting at sensory capabilities we haven't yet detected or understood. The existence of sensory worlds invisible to human experience reminds us how limited our perception is. We live in a narrow slice of reality, seeing only a small range of electromagnetic wavelengths, hearing only certain frequency ranges, unable to perceive magnetic fields or ultrasonic vibrations or infrared radiation without technological aids. Other animals inhabit the same physical world but experience it through completely different sensory arrays. A bee sees ultraviolet patterns on flowers that we cannot perceive without special cameras. A dog smells past events through scent trails invisible and meaningless to us. A bat builds three-dimensional models of its environment through echoes, perceiving space through sound in ways our vision-dependent brains struggle to imagine. As you relax into sleep, imagine being a sea turtle swimming through the ocean at night, hundreds of miles from any landmark. You sense Earth's magnetic field, not as something abstract but as a felt presence, subtle variations in field strength and inclination providing you with an innate sense of location. You know without knowing how you know which direction to swim, which currents to follow, which islands lie ahead. Your nervous system processes this information below conscious awareness, just as human brains process visual information and calculate trajectories for catching thrown objects without conscious mathematical calculation. You're following a route your species has followed for millions of years, guided by senses that feel as natural to you as sight feels to humans, navigating through a sensory landscape humans can only understand intellectually, never experience directly. Patterns in the sky. Earth's atmosphere creates a constantly changing gallery of visual phenomena. From the familiar blues of daytime and reds of sunset to exotic displays that few people ever witness. Among the most mysterious and beautiful are noctilucent clouds, the highest clouds in Earth's atmosphere, forming at altitudes of about 50 miles, higher than weather clouds, higher than most meteors burn up, at the very edge of space where atmosphere transitions to vacuum. Noctilucent means night shining, and these clouds earn their name through spectacular appearance. They become visible only during twilight, after sunset, or before sunrise, when the sun has dropped below the horizon for ground observers, but still illuminates these incredibly high clouds. They glow with an eerie electric blue or silver light against the darkening sky, often forming delicate wave patterns, streaks, and bands that shift and evolve as you watch. The formation of noctilucent clouds requires very specific conditions. At their altitude, temperatures drop to about -130 degrees Celsius, cold enough to freeze the tiny amount of water vapor that makes it to that height. The ice crystals form on condensation nuclei, microscopic particles that might come from meteor dust, volcanic aerosols, or even rocket exhaust. Recent increases in rocket launches may be contributing to noctilucent cloud formation by depositing additional water vapor and particles at these extreme altitudes. What makes noctilucent clouds particularly intriguing is their relative rarity in historical records. The first clear descriptions appear in the mid-1800s, shortly after the massive eruption of Krakatoa in 1883, which injected huge amounts of material into the upper atmosphere. For years, researchers thought noctilucent clouds might be related to volcanic activity. However, the clouds persisted and even increased in frequency long after volcanic aerosols dissipated, suggesting they represent a more permanent feature of the atmosphere, one that for unknown reasons wasn't prominently visible or wasn't systematically documented before the late 19th century. Climate change appears to be making noctilucent clouds brighter, more frequent, and visible at lower latitudes than historically recorded. This seems counterintuitive. If the lower atmosphere is warming, shouldn't the upper atmosphere also warm? But atmospheric physics doesn't work that way. Greenhouse gases trap heat in the lower atmosphere, but at extremely high altitudes, those same gases actually cool the atmosphere by radiating heat to space more efficiently. The result is that climate change warms the surface and lower atmosphere while cooling the mesosphere where noctilucent clouds form. Colder temperatures allow more water vapor to condense into ice, creating more abundant and brighter clouds. This means noctilucent clouds serve as a visible marker of climate change, a canary in the coal mine showing that human activities are altering not just surface conditions, but the entire atmospheric structure from ground to space. They're beautiful but ominous, their increasing prominence a symptom of planetary scale changes whose full consequences we're still working to understand. Another category of mysterious atmospheric lights are St. Elmo's fire, luminous glows that appear around pointed objects during thunderstorms. Sailors have observed St. Elmo's fire for centuries on ship masts during storms, interpreting the glowing lights as a sign of protection from their patron saint. The fire appears suddenly, typically as a blue or violet glow, sometimes with a hissing or crackling sound, lasting anywhere from a few seconds to several minutes. The explanation involves atmospheric electricity. During thunderstorms, powerful electric fields build up between charged clouds and the ground. When these fields become strong enough around pointed objects, they can ionize air molecules, stripping electrons from atoms and creating plasma. The plasma glows with characteristic blue-violet light, particularly intense at sharp points and edges where the electric field concentrates most strongly. Despite being well understood physically, St. Elmo's fire retains its dramatic impact. Pilots sometimes report seeing it on aircraft windshields or wingtips during thunderstorms, a glowing reminder of the powerful electrical forces surrounding them. The phenomenon is harmless in itself, though its appearance signals conditions favorable for lightning, making it a warning sign sailors and pilots learned to respect. An even rarer atmospheric phenomenon is ball lightning, which we discussed earlier, but it's worth noting how it relates to other electrical atmospheric phenomena. While St. Elmo's fire appears fixed to pointed objects, ball lightning moves freely through the air. While regular lightning strikes in milliseconds, ball lightning can persist for a minute or more. While sprites and jets extend upward from thunderstorms, ball lightning typically appears at ground level. The variety of electrical phenomena in Earth's atmosphere suggests that thunderstorms create conditions for several different types of plasma formation, each with distinct characteristics, and we likely haven't discovered all of them yet. Atmospheric gravity waves create another category of mysterious sky patterns. These aren't gravitational waves from black hole mergers, but rather undulations in the atmosphere caused by disturbances like mountains, weather fronts, or thunderstorms forcing air to move up and down. When conditions are right, these waves become visible as long parallel rows of clouds called cloud streets, or as rippling patterns in thin cloud layers. From the ground, you might see rows of clouds stretching from horizon to horizon with remarkable regularity, spaced evenly like an enormous washboard in the sky. The physics involves air oscillating up and down around its equilibrium height, similar to water waves after a stone drops into a pond, but moving through three-dimensional air instead of on a two-dimensional surface. When the oscillating air rises, it cools, and water vapor may condense into visible clouds. When it sinks back down, it warms, and clouds evaporate. The result is regularly spaced rows of clouds marking the crests of the atmospheric waves, with clear gaps between them where air descends. Atmospheric gravity waves can propagate hundreds of miles from their source, transferring momentum and energy through the atmosphere in ways that affect weather patterns and atmospheric circulation on scales much larger than the initial disturbance. They're invisible unless clouds form at just the right altitude to mark them, meaning most atmospheric waves pass unseen. But when conditions align and clouds reveal their presence, the result is geometric patterns in the sky of startling regularity and beauty, architecture in air created purely by fluid dynamics and thermodynamics. As you sink deeper into rest, imagine these atmospheric phenomena as Earth's way of making invisible forces visible. Electric fields become glowing plasma. Atmospheric waves become clouds arranged in impossible-seeming rows. Ice crystals at the edge of space catch light from the already set sun and glow silver blue against the darkening twilight. The atmosphere is never static, never simple, constantly churning and organizing and creating patterns that appear for moments or hours before dissolving back into formlessness. These patterns remind us that air is not empty space but a dynamic fluid, a sea we swim through without noticing, only occasionally revealing its movements and structures through ephemeral displays that make the invisible briefly visible to those patient enough to watch the sky. The deepest mystery, time itself. Among all the phenomena we've explored tonight, perhaps the most fundamental mystery is one we experience constantly yet hardly understand: the nature of time itself. Time seems simple at first consideration. It flows from past through present toward future. It marches forward relentlessly, never backward, never sideways. We measure it with clocks, organize our lives around it, feel it passing in moments of boredom and speeding by in moments of joy. Yet when physicists examine time closely, it becomes profoundly mysterious. The fundamental equations of physics are time-symmetric, meaning they work equally well whether time flows forward or backward. If you filmed particles interacting and played the video in reverse, the reversed interactions would still obey physical laws. There's nothing in the equations of motion, the laws of electromagnetism, or even quantum mechanics that says time must flow in one direction rather than another. Yet, our experience of time is completely asymmetric. We remember the past but not the future. Eggs break but don't spontaneously reassemble. Stars burn and eventually die. They don't grow younger and collect fuel. The universe has a clear direction even though its laws don't require one. This puzzle is called the arrow of time, and it connects to entropy, a measure of disorder in physical systems. The second law of thermodynamics states that entropy in a closed system always increases or stays the same, never decreases. Broken eggs have higher entropy than intact ones. Mixed cream and coffee have higher entropy than separated cream and coffee. The universe's apparent direction, from past to future, correlates with increasing entropy, from more ordered to more disordered states. But why should entropy increase? The underlying laws are time-symmetric, so why don't we see entropy decreasing just as often as increasing? The answer involves probability and the initial conditions of the universe. Ordered states are rare. Disordered states are common. There are many more ways for molecules to be randomly mixed than organized, so random changes tend to increase disorder simply because disordered states are more probable. The mystery shifts to why the universe started in such a highly ordered state, with all matter and energy concentrated, all entropy low at the Big Bang. If the universe had started with high entropy, there would be no arrow of time, no progression from order to disorder, no evolution of stars and galaxies, possibly no life or consciousness to wonder about these questions. The origin of the universe's initial low-entropy state remains one of cosmology's deepest questions. Some theories suggest that the Big Bang itself requires explanation, that our universe might be part of a larger multiverse where different regions undergo their own Big Bangs, each creating a local pocket with temporarily low entropy. Other theories propose that the universe might be cyclical, undergoing endless expansions and contractions, with entropy resetting at each bounce. Still others suggest that our understanding of entropy in quantum gravity contexts might be incomplete, that there are principles we haven't yet discovered that explain why universes naturally start in low-entropy states. Our perception of time also raises mysteries. Einstein's relativity teaches that time is not absolute but relative, that it passes at different rates depending on velocity and gravity. An astronaut traveling at high speed ages more slowly than someone on Earth. Someone at the top of a building experiences time slightly faster than someone in the basement, because gravitational time dilation is weaker further from Earth's center. These effects aren't illusions or artifacts of measurement. Time genuinely passes at different rates in different circumstances. Atomic clocks on satellites must be adjusted for both the speed they travel and their altitude, or GPS navigation would accumulate errors. This relativity of time seems to contradict our experience of a universal now, a present moment that everyone shares. But relativity tells us there is no universal now, no absolute simultaneity. Events that are simultaneous for one observer happen at different times for another observer, moving relative to the first. The present moment is observer-dependent, local rather than universal. This has profound implications for how we think about existence. Does the past still exist somewhere? Does the future already exist, waiting for us to catch up to it? Or is only the present real, with past and future being useful concepts without physical reality? These questions touch on the philosophical problem of temporal experience. We feel that we move through time, that the present moment shifts from past toward future. But the equations of physics describe a four-dimensional spacetime where past, present, and future all coexist as different regions of the same structure. From this block universe perspective, time is more like space, a dimension we extend through rather than something that flows. Your entire life, from birth to death, exists as a four-dimensional path through space-time, all of it equally real, with your consciousness experiencing different moments of this path sequentially, but the path itself being fixed and complete. Yet this conflicts with our experience of free will, of making choices that determine the future. If the future already exists, how can our choices matter? Philosophers and physicists continue to debate whether the block universe picture requires determinism or whether quantum mechanics introduces genuine randomness that preserves meaningful agency. These are not merely abstract philosophical puzzles. They touch on fundamental questions about consciousness, causality, and the nature of existence itself. Another temporal mystery involves the relationship between time and consciousness. We experience time as flowing, as a sequence of moments where the present continually moves forward. But does time actually flow, or is flow an illusion created by how consciousness processes memories and perceptions? Some philosophers argue that flow is fundamental, that presentism is correct and only the present moment exists. Others argue that flow is illusory, that the block universe is correct and the feeling of time passing emerges from how our brains organize memories and anticipations rather than from anything objective about time itself. Recent neuroscience research has revealed fascinating insights about how brains construct temporal experience. We don't perceive time directly, but rather infer it from sequences of events, changes in our environment, and memories of past states. The brain's now actually encompasses about 2 to 3 seconds, a window during which events seem simultaneous even though they occur sequentially. This explains why we hear words and music as continuous streams rather than disconnected sounds. Our neural processing smooths brief intervals into unified experiences. Brain regions involved in timing include the basal ganglia for durations up to a few seconds, the cerebellum for very precise sub-second timing, and prefrontal cortex for longer intervals and temporal planning. Different neural systems handle different temporal scales, from milliseconds to minutes to days, suggesting that our unified experience of time emerges from multiple specialized timing mechanisms working together. When these systems malfunction, temporal experience can fragment. Some neurological patients lose the ability to perceive event sequences. Others can't estimate durations, Still others lose episodic memory and thus lose their sense of extended personal history. The quantum realm adds yet another layer of temporal mystery. Quantum mechanics describes systems in terms of superpositions, where particles can exist in multiple states simultaneously until measured. But what determines when a measurement occurs? What makes now special enough to collapse superpositions into definite states? The measurement problem in quantum mechanics is partly a temporal problem. Understanding how the deterministic evolution of quantum states transitions into the definite outcomes we observe. Some interpretations of quantum mechanics, like the many worlds interpretation, eliminate special status for the present by suggesting that all possible measurement outcomes occur, with reality branching into multiple parallel versions whenever quantum systems interact. From this view, the present moment you're experiencing is just one branch among countless others, all equally real. Other interpretations, like collapse theories, suggest that something physical happens during measurements, some objective process that picks out one outcome and eliminates others, making the present moment physically special in ways we don't yet understand. Time travel scenarios, while mostly in the realm of science fiction, also probe temporal mysteries. General relativity permits solutions to Einstein's equations that include closed time-like curves, paths through space-time that loop back on themselves, potentially allowing travel to one's own past. Whether such solutions exist in our actual universe remains unknown, and if they do, whether they're traversable by anything more massive than a photon is questionable. More importantly, time travel to the past seems to create paradoxes. If you travel back and prevent your own birth, what happens to you? Most physicists suspect that some principle we haven't yet discovered prevents these paradoxes, possibly by forbidding closed time-like curves or by ensuring that any attempts to change the past automatically fail. Forward time travel, by contrast, is well established and actually occurs routinely. Any object moving relative to others travels forward through time more slowly from its own perspective than from an external observer's perspective. Particles accelerated to near light speed in particle accelerators age far more slowly than stationary particles, exactly as predicted by special relativity. In principle, an astronaut traveling in a very fast spacecraft could age only a few years while centuries pass on Earth, experiencing their own form of time travel. The catch is that returning to the original time is impossible. Relativistic time dilation only moves you forward, never backward. As you drift towards sleep, consider that you're experiencing one of reality's deepest mysteries at this very moment. Time is passing, each second following the last in sequence that seems inevitable yet remains unexplained at the most fundamental level. Your consciousness rides along this sequence, experiencing what you call the present moment, remembering what you call the past, anticipating what you call the future. Yet the nature of this flow, whether it's real or illusory, objective or subjective, determined or open, remains one of philosophy and physics' most persistent puzzles. Time might be the most familiar yet least understood aspect of existence, something we measure with atomic precision yet cannot fully explain or define. As you lie here, feeling sleep approaching, consider what we've explored tonight. Ancient structures that challenge our assumptions about early human capabilities. Cosmic signals reaching us from billions of years ago. Strange lights in the sky and sounds in the ocean that stretched the boundaries of credibility until confirmed. Patterns in nature that emerge from simple rules playing out across scales. animals navigating by senses we cannot feel, quantum entanglement connecting particles across vast distances, the very nature of time itself, familiar yet mysterious. Each of these phenomena reminds us that the world contains far more than our daily experience suggests. We live in a universe that constantly surprises us, that reveals new layers of complexity and beauty the more carefully we look. The mysteries we've discussed tonight aren't frightening or unsettling. They're invitations to wonder, reminders that curiosity never exhausts itself, that there will always be new questions to ask and new puzzles to solve. Science doesn't diminish wonder by explaining mysteries. It reveals deeper mysteries beneath each explanation. We understand the physics of auroras, yet the quantum mechanisms of bird magnetoreception remain unclear. We've mapped the human genome, yet consciousness remains unexplained. We can predict planetary motions with extraordinary precision, yet cannot forecast weather more than a few days ahead. Each answer generates new questions. Each solution exposes new problems, in an endless progression that suggests understanding itself might be an infinite journey with no final destination. This is comforting rather than frustrating because it means the human project of discovery can continue indefinitely. No generation will exhaust knowledge. No era will solve every puzzle. Your children's children will have mysteries to explore that we haven't even imagined yet. Questions that couldn't be asked until technologies not yet invented create ways to observe phenomena we currently cannot detect. The universe's generosity in offering endless mysteries matches our species' insatiable curiosity, creating a perfect pairing that drives exploration and discovery forward. Think about the researchers mentioned tonight, the scientists who spent years, sometimes entire careers, pursuing single questions. The astronomers who monitored fast radio burst sources for months to catch enough data to draw conclusions. The geologists who installed instruments on racetrack playa and waited 2 years for rocks to move. The marine biologists who deployed hydrophones decades ago that are still listening to ocean sounds today. The physicists who spent lifetimes closing loopholes in quantum entanglement experiments. These patient observers exemplify a profound truth. Some questions deserve slow answers, careful answers, answers built from years of accumulated observations rather than rushed to premature conclusions. Their patience comes from understanding that mysteries aren't problems to be eliminated, but rather phenomena to be understood deeply, from multiple angles, with respect for their complexity. They know that quick explanations often turn out to be wrong, that nature rewards careful observation and skepticism about easy answers. They've learned to live with uncertainty while working to reduce it, to accept that today's best understanding might be tomorrow's footnote as new data emerges and theories evolve. We live in an era where instant answers are expected, where search engines provide responses in milliseconds, where impatience with uncertainty is common. Yet the most important questions cannot be answered quickly. They require sustained attention, collaborative effort across years or decades, willingness to be wrong and start again with better approaches. The mysteries we've explored tonight honor this slower, deeper way of knowing, reminding us that some truths reveal themselves only to those patient enough to wait and careful enough to listen. As sleep approaches, let these mysteries comfort you. The universe is not fully known, not completely mapped, not entirely understood. Tomorrow, somewhere, a researcher will notice something unusual, an observation that doesn't fit current theories. Perhaps it will be dismissed as error. Perhaps it will spark new questions. Perhaps, after years of investigation, it will reveal something fundamental we didn't know about how reality works. The process continues endlessly, each generation adding to collective understanding while discovering new horizons of ignorance, new frontiers of mystery. You are part of this story, not as a scientist necessarily, but as a conscious being wondering about existence. Every time you look up at stars or wonder how birds navigate or feel curious about sounds in the night, you participate in the human project of trying to understand. The questions don't require answers to have value. The wondering itself matters, the openness to mystery, the recognition that we inhabit a reality far stranger and more beautiful than common sense suggests. The ancient peoples who built Göbekli Tepe wondered about the cosmos and carved their observations in stone. Scientists today wonder about fast radio bursts and deploy telescopes to capture them. Future generations will wonder about mysteries we haven't encountered yet, using technologies we haven't imagined. The chain of curiosity extends backward to the origins of consciousness and forward to the unknowable future, connecting all wondering minds across time through shared questions about existence, meaning, and the nature of reality. Sleep comes as your own small mystery, a daily transition from consciousness to unconsciousness and back, a process we experience constantly yet cannot fully observe or understand. In sleep, your brain continues working, processing memories, consolidating learning, maintaining your body's functions without conscious direction. Dreams might come, strange narratives assembled from memory fragments and random neural activity, meaningful yet chaotic, personal yet universal. You'll wake tomorrow with no memory of most of tonight, yet tomorrow your brain will function differently because of tonight's sleep, changed in ways you cannot observe or measure but which nonetheless shape who you are and how you think. Let the mysteries hold you tonight. The ancient stones standing in Turkey, the cosmic signals reaching Earth after journeys lasting billions of years, the whale songs propagating through ocean depths, the quantum entanglement connecting particles across space, the fairy circles dotting African deserts, the time flowing past to future carrying you along its current toward tomorrow. All of it mysterious, all of it real, all of it part of the vast, strange, beautiful universe you inhabit. Rest now, knowing that mysteries surround you, protect you, invite you to wonder, promise you that the world will never stop being interesting, never run out of questions, never cease revealing new layers of complexity and wonder to those patient enough and curious enough to look. Before you drift completely away, remember to like this video if you enjoyed exploring these mysteries, and subscribe to Deep Science Sleep for more sleepy science stories that bring wonder and calm to your nights. Until next time, sleep well, dream peacefully, and know that the universe is out there being strange and beautiful while you rest. The mysteries continue while you sleep, patient and eternal, waiting for tomorrow's observers, offering endless invitations to wonder, creating the inexhaustible beauty of a universe that reveals more the closer we look, promising that curiosity will never run out of questions to ask or wonders to discover. Rest now, wrapped in mystery, cradled by curiosity, knowing the journey of understanding never ends and the invitation to wonder never expires. Good night.